Back for the next session. I need your attention. So remember, work is only done when a force is applied on an object and that object moves through a distance s. If a force is applied and the object does not move, then it means there is no work done. There is zero work done. Work is only done when there is change in distance of a particular object. Then for this man you are seeing here in the diagram, this man is pushing a lawnmower. A lawnmower is that machine which we use for slashing compounds, like those compounds are in the hotels, compounds around the hospitals. We use a lawnmower. So we are asking ourselves, is it easier for this man to pull it or to push it? Now you find that it is easier to pull. It's easier to pull it than to push it. There are some reasons why it is easier to pull it than to push it. So in the first question, in this diagram, I tried to summarize an energy diagram showing this one, an energy diagram showing the forces that the man is applying on the lawnmower and the other forces due to the weight of the body. So mg is the weight of the body and r is the normal reaction, the reaction because there is weight of the body. Whenever a body has weight, there is always a reaction against that weight, so it is that r comes because there is weight. Then a force is being applied on that lawnmower or that object there, or a table, anything like that. A force is being applied at an angle theta above the horizontal. So this man is pushing. So when you push, when this man pushes this object, it's like it's going to move forward. So as it moves forward, there is a friction opposing the motion. Now this force, as we know, it has two components, a horizontal component and a vertical component. The horizontal component is F cos theta, which helps this object to move forward. The vertical component, which is even downwards, is F sine theta. Now F sine theta is going to be in the same direction as the weight. So when you add the two, mg plus F sine theta, now that means the resultant weight is going to be too big. Now because the weight has increased, then it means that even r is going to now that the weight has increased, it means more weight is being applied. This body has more weight, and that more weight is going to make the reaction to increase, because the reaction increases because the weight has increased. And remember, the normal reaction is directly proportional to the frictional force. So that means even the frictional force is going to increase. Then that will make it very difficult for you to push this object forward since the frictional force has increased. Unlike if this man was pulling, if he was pulling, then that means this arrow of which is F, which is facing downwards at an angle theta, will be facing upwards. The component of F will be upwards. Then we will have F sine theta but upwards. Then we have F cos theta towards your right. Now we are interested in F sine theta, which is upwards. Now that means if the weight is mg minus F sine theta, which is upwards, then it means the resultant weight of the body is going to reduce. Now when the resultant weight of the body reduces, then it means even the normal reaction is going to reduce, because the normal reaction depends on the weight of the body, which is now the resultant weight. Now from there, we know that normal reaction is directly proportional to the frictional force. Then since the normal reaction has reduced, even the frictional force will reduce. And that will mean that pulling the body becomes more easier since the friction has reduced. So you can easily pull that table than pushing it. So pulling is more easier than pushing. Thank you very much. Let me come back for the next session, which we are going to talk about work done by a force of pressure. Thank you very much.